In part 2 of our series on the 4-jaw chuck, we started to talk about centering a piece of square work in the 4-jaw chuck, but I decided to leave that until this video, so let's dig into that now. These two ends weren't very well centered. Let's suppose, just for the sake of discussion, that I now need to put a hole right in the center of this side. To do that, I'm going to have to make sure I have it properly centered, and let's go ahead and look at how we do that. If you have a surface plate and a height gauge, you can use them to mark the center, and then it makes it real easy to drill a hole in the center of any of the faces. So I'm going to go ahead and demonstrate that. You can use magic marker instead of layout die, but I prefer the layout die just because the magic marker tends to rub off on your hands and on your clothing or anything else it comes in contact with, so just a little messier to use. And since I have the layout die, I'll go ahead and use that. So you just want a very small amount. And then it takes a minute or two to dry out. I can speed up that process. I have a little fan back here on the back of the surface plate. That breeze, especially if I move the piece up close to it, will help to dry a lot quicker. If you're just getting started in the hobby, you probably don't have a surface plate and a height gauge. In my own shop, it was quite a while before I got those after I had the lathe. But I'll show you an interesting little trick here. You can pick any piece of metal or scrap as long as it's reasonably smooth, and in this case I'll use a little snap blade knife, and if this piece is close to half of the height of the part you want to mark, you can just use any reasonably flat surface, in this case just a countertop. It's got a bump of epoxy on it though, and we'll scribe a line here, flip it over, scribe another line, flip it to the next side, and then the next side, and you can see with those 4 scribed lines we can actually approximate the center pretty closely. And of course, if you have another block that will get you a little bit closer, you can repeat that process, and within a few tries you can actually zero in on the center of the workpiece pretty well without ever having measured anything. Try it again. This time I'm just using another piece of scrap, which is a little shorter than the one we just used. I think will bring us closer to the center, at least in this dimension. Let's try that. And there we go. So we're converging. You can see the center is right about there. And now I'll put it on the height gauge and mark where it actually is and see how close we got. The way I use the height gauge is first make sure the tip is clean. You don't want any chips or grit underneath the tip. And the surface of your surface plate, you want to make sure that's reasonably clean. Then you can just bring your tip down to the surface plate, zero your height gauge. I'm using metric scale, but it doesn't really matter because whatever the number is, I'm just going to divide it in 2. So whether it's inches or whether it's millimeters, either way will work. So I'm getting a reading of 31.24, and since I'm not real good at mental math here, I'll come over here to the calculator and punch that in, and then we'll divide by 2 to get the halfway point, 15.62. So now I'm going to set my height gauge to 15.62. It's hard to see this digital readout, unfortunately, with the lighting. 15.62. 61, close enough. Now we'll scribe our line. And we'll repeat that in the other dimension. First we'll make sure it's zeroed. Should be still zeroed, but we'll double check. Measure the height, 25.36. Now I'll go over to the calculator. Divide by 2 gives us 12.68. So we'll move it down to there. Got that, and now we scribe our line. This accurately measured dimension actually is very, very close to the mark I made just using our very crude measuring instrument, or our crude approximator. So the point being that you don't necessarily have to have expensive equipment. It's nice to have, certainly, and if you've got the money, go for it. But if you're starting out, or you're just real limited on funds, or would rather spend your money on something else, there often are ways you can get to the desired end result, even with some degree of precision, even without so-called precision tools. I went ahead and marked the center point on the other side using some blue layout dye this time. And I'll show you how we can use that center point as a reference to zero in on the center of the workpiece in the 4-jaw chuck. So with our layout die and our crosshairs here, I've now mounted it in the 4-jaw chuck, and in the tailstock chuck I've placed a small pointer or pointed tool, which actually came from one of those sets of 50 small tools that you can get from Harbor Freight or Grizzly or other sources. One thing that's nice about this method is it's pretty self-explanatory, because you just keep adjusting it until you've got the pointer lined up over the crosshairs. So it's easy to understand, not much to get confused about. But I'll probably find something anyway. Alright, so let's start out with it in this orientation. As you can see, the horizontal crosshair is below the point, so I want to raise the workpiece up. So I'm going to loosen this top jaw to give me some clearance here into which I can push the block. So I'll now flip it over 180 degrees and tighten the opposite jaw, and that will bring it a little more on center. And I'll bring that a little closer, but I'm not there yet, so we'll repeat that. I need to flip it back over, make a little more clearance, and push it down. Okay, now we're getting pretty close in that dimension. Let's see if we can do it one more time here. So we'll open this jaw just a little bit, flip it over, and push it down closer to the line. Let's leave that one for now. Then we'll go to this other jaw, other dimension here. I'm going to loosen it, flip it over, push it down. Oops, went the wrong way with that one, sorry. So let's do that, try that once again. One thing that you have to be careful of is if you have these two jaws are too tight, it makes it hard to push it in the other direction. So you want to, don't make these too tight. Early in the process you want to keep the jaws just snug but not tight, so you have freedom to move the workpiece. Now, as you can see now, we're getting pretty close. Now, if I really want to get it close, which I do in this case, my eyesight's not that great anymore. I'm approaching 70 years old, so I'm going to use my magnifiers and see if I can get a better look at it here. Well, that's good enough. I think you get the point, and not to make a pun, but what the heck, if I get one for free, we'll use it. So, not to put too fine a point on it, but I think we're close to where we need to be, as you can see, and I think how we got there was pretty self-explanatory. This is the setup I use on the mini lathe for centering work in the 4-jaw chuck. Because space on the mini lathe is so limited, I've chosen to leave access to the chuck jaw up here where I can get to it easily and turn the chuck key without running into anything. But then I have to put the dial indicator down here. Now the problem is that the dial indicator is reading in the horizontal plane, but we're making the adjustments in the vertical plane. So every time after we take measurements, we have to flip the chuck around by 90 degrees, then make our adjustment, and then flip it back 90 degrees to check again against the dial indicator. So that's just one of the compromises that are a result of the tight space on the mini lathe. When you're centering the workpiece, you don't want the jaws to be very tight. You should just have them clamped snugly on the work, but you have to leave enough freedom of movement so that you can slide the workpiece to one side or the other to bring it on center. If the jaws are real tight, you'll have trouble doing that. So I've set up the dial indicator so that the probe is just about in the middle of the side of the workpiece here, not too high up or too far down, but right in line with the midpoint of the chuck jaws where you want to have that. Now, as you can see, when I turn the chuck back and forth, the needle on the dial indicator goes through sort of a null point, or right there, and that's what we're going to use as our reference. So I'll turn the bezel here until I have the 0 under the dial. I'm going to pull out on the back side of the plunger, and that withdraws the plunger so it's no longer in contact with the work. And that's important because if you try to rotate the workpiece with the plunger in contact, it's going to knock your dial indicator out of position. So pull the plunger back, then you can rotate this around 180 degrees. And now we're going to repeat that process that we followed on the first side. You can see there's the null point. Now, the previous null point on the opposite side was about 6 thousandths or 7 thousandths apart from this. So that tells us we're about half of that distance, or about 3.5 thousandths off center. So our goal now is to push the workpiece in the appropriate direction to bring it closer to on center. Now, as you can see, if I pull out on this plunger, the needle moves in the desired direction, which is to say we want to get it towards 0. That tells me if I push the workpiece in the same direction, then that will bring it closer to 0. I need to bring this face up to the top of the rotation so that I can now push it down. Obviously you can't pull it, so your only choice is to push it from the side where it needs to move downward. So we'll do that now. I'll put a little bit of pressure on the workpiece by tightening the jaw. Now I'm going to rotate it 180 degrees to the opposite jaw, and I'm going to loosen it just a little bit. So I'm applying pressure and then I'm releasing pressure, and that will let the workpiece move a small distance in the desired direction. Now we have to bring the side we were measuring against back into place here. You can see there's our 0 point. We'll re-zero it here since it's moved. Flip it around 180 degrees to the opposite jaw, and you can see we're now within about 1.5 thousandths. And once again, we need to move it in this direction, or move the workpiece this way. So we'll bring that side up here, and we'll apply pressure. This is the number 3 jaw, and then we'll check again. And we're even closer now. Okay, so we're on 0. Flip it around 180 degrees, and we're nearly on 0. So we're about off by just a little over 1,000th now. And I want to again push it in this direction. So I'm going to bring the number 1 jaw up now, put a little pressure on it, and hopefully that will be enough to get us where we want to go. Okay, we'll re-zero the indicator, come around 180 degrees to the opposite side, and we're within about 0.5 thousandths now. So I want to stop there, then we'll do the same process for the other 2 jaws, the number 2 and the number 4 jaw. And now with the number 4 jaw pointing towards me, I'll repeat that, finding the null here, set the 0, withdraw the plunger, flip the workpiece around 180 degrees to the number 2 jaw, and now you can see we have about 12 thousandths of offset, which tells us we're about 6 thousandths off center. And again, we want to, you can see in this case, if I pull back on the plunger, the dial moves in the wrong direction. So I want to come back around. So I want to set it to 0 here. This is my high side, or high being closer into the dial indicator. Now we'll flip it around to the opposite side, and now we can see that we've got about 12 thousandths to go. And as before, we want to push the workpiece in this direction. Now because we have a 12 thousandths to go, I'm first going to loosen up on the near jaw, the number 4 jaw, and that will provide just a little bit of clearance for the workpiece to move into. Now flip it around 180 degrees and apply pressure on the number 2 jaw, and that will push it down into the space we created. And with some luck, we'll hopefully be closer now. Right, there's our number 4 jaw. and our number 2 jaw. So let's zero it here on the number 2 jaw. Flip it around to the number 4 jaw, and we're actually very close. That was more luck than skill. So now we're zeroed both ways here on the number 2 and the number 4 jaw. Now let's go back and recheck our number 1 and number 3 jaw. They're going to zero at a different point. So because it's narrow, the workpiece is narrower in this direction than it was in the other direction. But the process is the same. So we zero it, pull out the plunger, rotate 180 degrees, and you can see we're right on 0. So there you have it. You may have noticed that during this video and some of the preceding videos on the 4-jaw chuck, I used several different methods to bring the workpiece on center, depending on how far I needed to move it. And I'd like to just review those. This will give you some ideas about which method works in which situation. Method 1 is when you need to, you're first putting the workpiece into the chuck and making some very coarse adjustments just to visually or by eyeball to bring it on center. So you're making movements of greater than about 2/10 of an inch. In that case, just adjust the chuck jaws so that they approximately fit the work, then insert the work, and then adjust your opposing jaws until the amount that they extend beyond the body of the chuck is approximately equal on opposing sides. So that'll bring it roughly into center. Then you can go to method 2, which works well, going from about 20 thousandths to about 200 thousandths or 2/10 of an inch. And in this case, this is the situation where we first loosened what I'll call the lower jaw to create some space into which to move the work, and then tighten the opposing or upper jaw to shift the workpiece into that space that we created. So that pushes the workpiece closer onto center. Method 2, when you start to get very close to the center point, you're just a few thousandths off center. Method 2 often will overshoot, and so method 3 is helpful when you're very close. You're within about 5 to 20 thousandths, and the difference is that in this case we don't create a space. We just first tighten what I'll call the upper jaw and apply pressure first on the upper jaw, and then we just gradually, or just a small amount, loosen the lower jaw. And as you loosen the lower jaw, that pressure that you created from the upper jaw will tend to push the workpiece by a very small amount, just a few thousandths, closer onto center. So this is good for making very fine adjustments. And then at the very final step, where you might be only 1 or 2 thousandths or 3 thousandths off center, you can often get that final centering adjustment simply by tightening the one jaw that you need to tighten, which I've called the upper jaw, to push the workpiece closer to center. So I hope those are helpful to you, and you can experiment with them. But with practice and experience, you'll sort of intuitively use these methods without really necessarily thinking about it. Before I wrap up this video, I wanted to show you how I'm holding the dial indicator in place. But one of the tricky parts is trying to figure out how to hold the indicator in a convenient position. And the way I've chosen to do that here is I have this magnetic base indicator, and I have my compound turned parallel to the ways, which is often the way I keep it. And I just clamp the magnetic base onto the top of the compound slide. This particular type of indicator, this particular one, is a brand name Noga, N-O-G-A, and they are, in my opinion, pretty much the gold standard for magnetic base indicator holders. You have this single knob here, and you can work the arm around wherever you want it, and then just tighten that knob, and there you go. So very easy to use, very flexible in terms of getting it to fit in a space like this one, which may be awkward. Now, you may have seen indicator holders like this one. This is the first one I bought many years ago, probably 30 years ago or more. And often these are what beginners start out with because they're relatively inexpensive. But what you find is when you use it for a while, they're also very cumbersome. You have two adjustments to make, and the adjustments don't necessarily move the indicator in the plane that you want it to move in. And so you spend a lot of time fooling around with this thing and just trying to get the indicator in place, compared to the ease that you just saw with the Noga type. But the Nogas tend to be pretty expensive. This one's probably on the order of $90 in 2018 dollars. But there are some good imports that basically work the same way, the single arm design, but are a lot less expensive. This one is from LittleMachineShop.com. It's their product number 2880, and I believe it sells for about $40 in 2018. So not quite as good as the Noga, but almost as good and a lot less expensive, so about half the price. So that could be a good compromise for you if you want to get one of these. You can also get little mini versions that might work for you, but they often don't have as much strength. They don't hold as rigidly, and so you may have trouble getting it to hold the indicator firmly. But I bought some of these on Amazon. I think this one came from Amazon, and LittleMachineShop.com also sells some similar to these. So you might want to try one out. They're less expensive and work in situations like this where you may be tight on space.